A very good afternoon. Today we are going to discuss about one of the important concept of sustainable business, which is greenhouse gas and the carbon footprint. So when we talk about climate change, we are essentially talking about the greenhouse gas emissions. These emissions are generally not abstract s- scientific jargon. They are the invisible threads which are connecting the energy uses, agriculture, industry, lifestyle choices, and public policy. At the most basic level, greenhouse gas emission means the release of certain gases into Earth's atmosphere. So basically, through natural processes and more importantly, through human activities. Whatever we are performing, the trap heat and warm the planet. So basically, we could say that this is the warming process, and this warming process is known as the greenhouse effect. So generally, like in winter season, we decided to use blanket, sleep comfortably. In the similar manner, Earth wears a blanket by default. Earth wears blanket, and as a human, what we are doing, we are adding five more blankets. So it's now the planet can't sleep comfortably because the layering is being increased by us, by the human interaction. Let us first understand the greenhouse, natural greenhouse effect, because without it, uh, life as we know it is not going to exist. Sunlight reaches Earth mainly as shortwave radiation. Then these rays pass easily through the atmosphere and warm Earth's surface. The Earth is going to release this energy back as long wave infrared radiation. So basically, greenhouse gases, they are absorbing the outgoing infrared radiation and then re-emit it in all directions, including back towards Earth's surface. So this is going to create a warming blanket effect. Without this natural process, the Earth's average surface temperature. So basically, without this natural process, the Earth's average surface temperature is going to be about minus 18 degrees Celsius. With it, the current average temperature is about plus 15 degrees Celsius. So we could say that the greenhouse effect is not the real villain. The problem is the too much of it the caused by human activities. So greenhouse effect is always going to be, but since we are increasing the temperature, we are increasing the effect, this is the real problem. Now, an important question which may arise that if the atmosphere is mostly about the nitrogen and oxygen, why don't they cause warming? Then nitrogen, we all know that in the atmosphere, the 78% is nitrogen and oxygen is about 21%. So this is very common. These gases are transparent to infrared radiation. Greenhouse gases are different because their molecular structures vibrate at infrared wavelength. This allows them to, at the same time, absorb and re emit heat. So it's not about it's not about the quantity alone, it's about the ultimate behavior of the molecules. Then let's know about the exact flow of energy, how the energy flows through various steps. The first one is 100% sunlight reaches to Earth, then about 30% is being reflected back to space. So basically, we could see that to the clouds, ice on surface. Then from that, about 20% is absorbed by the atmosphere. So now out of 100%, 30% is reflected back to space. It has been returned. Then 20% is absorbed by the atmosphere. Now remaining 50% is going to reach Earth's surface and it's warming it. So basically the lights which we are receiving is the 50% of the total sunlight. The warm surface emits infrared radiation upward and greenhouse gases absorb part of this radiation. Then they re-radiate it, and when they re-radiate it in upward direction, it is going towards the space. When they re-radiate it downward direction, it is moving towards the Earth's surface. So the downward re-radiation is that trap heat near the surface. This is the warming loop. So in the re-radiation also, the downward re-radiation is the actual reason due to which the heat is being trapped near the Earth's surface. Now there are naturally greenhouse gases include water vapor, carbon dioxide, and methane. Very common one, and this has been uh, in we know through the Kyoto Protocol framework as well as through the Paris Agreement also. However, since the Industrial Revolution, human activities have increased atmospheric greenhouse gas concentration by more or less by 50% and accelerated warming at very unprecedented rates. And this is why climate change today is totally anthropogenic, which is, we could say that it is a human driven also. So, as per the international climate framework, we all know that carbon dioxide is the largest contributor to the anthropogenic warming, and the sources of carbon dioxide are fossil fuel combustion, deforestation. Fossil fuels implies the coal, oil, gas, which we are using for the energy purpose, for the transportation, for the industry, and then deforestation and the cement production. So the cement industry is the one of the major contributor to the carbon dioxide. Now, the carbon dioxide has a longest atmospheric lifetime. So basically, hundreds to thousands of years they are going to be in the atmosphere. Next contributor is the methane. It is much more potent than carbon dioxide, but in the shorter term. Why shorter term? The lifetime of methane is going to be almost equal to uh, 12 years. Now, the sources from which methane is being produced through the agriculture, livestock, rice cultivation, landfills, and the leaks of the fossil fuels. The third and the one of the important contributor is the nitrous oxide, N2O. The lifetime of N2O is the 116 years, 116 years, and it is largely generated from the use of the fertilizer. the synthetic fertilizers, which are being used by the farmers, manure management, and industrial processes. Then we have one more contributor, fluorinated gases, F gases, which are being used in largely in the refrigerators, air conditioners. So when we talk about fluorinated gases, which is also known as F gases, then they have HFC, PFC, SF, and NF3. So these have a extremely high warming potential. They are being used in very small quantity, but the we will see in the upcoming slides that they have a very huge impact in comparison to the uh, CO2 and CH4, carbon dioxide and methane. India is currently the third largest global greenhouse gas emitter globally, contributing about 7 to 8% of total emissions. As per the latest data, total emissions excluding LULUCF, the total emission in 2020 is 2,959 metric tons CO2 equivalent. Net emissions, including sinks, is 2,437 metric tons CO2 equivalents. And as per the recent estimates, recent means around 2023-24, it's approximately 3.5 to 4 CO2 equivalent. And when we are sectorally, we want to know, then energy and power is the greatest emitting sector, approximately that 70 to 75% of the total emission. Then agriculture, followed by the agriculture, 15 to 20%. So major emission is being done by the energy and power companies as well as by the agriculture sector. And when we decide on the basis of the gases, the major contribution is of the CO2, as I already told you, then CH4, methane, then nitrous oxide. To compare the gases and the impact of each gases on the environment, the scientists use mm, quantitative framework, a measurement scale which is known as GWP, global warming potential. So let's know what is the global warming potential. Basically, global warming potential is a metric which measures the heat trapping ability of a greenhouse gas relative to CO2 over a specified time horizon. What it means? It means that it is measuring how much heat a gas traps in comparison to carbon dioxide, and it is being evaluated over a time period. The standard metric is 100 years, global warming potential of 100 years as per the IPCC guidelines, which allow the conversion of emission to CO2 equivalents for comparable impact assessment. So basically, all the gases are being converted into CO2 equivalents, and the reason is that they are being converted because we can't say that 1 ton of methane is equal to 1 ton of carbon dioxide, because it might be possible the quantity of CO2 is larger, but the impact of methane is more harder than the CO2. So we have to convert all these into a similar parameter so that we could compare. It would be easier for us to compare the impact of all these gases across a time period. So these are being converted. The emission is going to be expressed in CO2 equivalents, which is represented by CO2e. This is the latest value from IPCC sixth assessment report. Uh, that's why it has been written that AR6 in 2021. Carbon dioxide, since it has been taken as the reference gas, that's why the global warming potential for 10 years is 1. We are using 1. Methane, for the methane, it is 27 to 30. It is shorter lived, but 80 to 85 times stronger over 20 years. Then we have nitrous oxide, which have a 273 in comparison to CO2. It is long lived, but also, and this has a more depleting effect on ozone. Then we have fluorinated gases. They are going to be live longer, 100 to tens of thousands years. And this is approximately they are going to suppose SF6. It is going to be for 25,000 years. So basically, this data explains why even the methane leaks have outsized short-term impact. Suppose when we are comparing the impact of methane to the impact of fluorinated gases, the impact of methane is going to be the shorter, because 1 ton of methane is going to be the 28 to 30 tons of CO2e over 100 years, but A to 285 over 20 years. So in the for initial 20 years, the impact of methane is harder. So in India, high methane from agriculture and high nitrous oxide from nitrogen fertilizers are amplifying the warming despite the lower volumes than CO2. So we could say that in the summarized way that it might be possible the quantity of CO2 is larger in comparison to the other gases, but the impact which the methane, nitrous oxide, and fluorinated gases are creating on the surface of the earth, they are much harder than the CO2. Reducing these short-lived gases offers quicker climate benefit, and these are going to complement long-term CO2 cuts from coal phase down as well as the renewables expansion. So always it is not necessary that when we are judging the something, that result could be as evident as we are getting through it. So basically, the methane, nitrous oxide, nitrogen oxide, and the fluorinated gases, they are the small package but big impact. So we could say that they have a, don't judge them by the size. They are lesser in quantity, but they have a huge impact. And here impact means the negative one. The next topic is the of the carbon footprint. We will see this in detail, but for now, let's know what is the carbon footprint. Carbon footprint basically it is the total quantified amount of greenhouse gas emission. So the suppose any individual, organization, product or service event or the activity which they are using, whether the indirect form or in direct form, whatever they are causing the emission of the greenhouse gases, the total impact, the total quantity of the greenhouse gas emission is known as the carbon footprint. So the it is the sum of the emission from the various sources like use of the energy, transportation, manufacturing sector, agriculture sector, waste and supply chain. And again the measurement is going to be, the footprint is again going to be measured in the CO2e, the carbon dioxide equivalent, because everything is being converted into the CO2e, which typically comes in form of the tons or kilograms. And the purpose of conversion, we all know that the purpose of conversion is to allow a single comparable metrics for the climate impact, so that it would be easier to know the exact impact. And for that purpose, the every gas is being converted into a single unit. So that's all for today. We are going to discuss next topic in the coming classes. Thank you.